Lesson 2.4 deals with operations with complex numbers. So we've already talked a little bit about what I means, what I squared is. Remember that I squared is -1. So we want to make sure that we remember that. I squared equals -1. Whenever we see the I squared, we're always going to change it to -1 no matter what. All right? So when we are dealing with complex numbers, remember complex number is anything that is a plus bi. That's the general form of it. So a is a real number plus bi, which is a real number plus an imaginary number. We are allowed to add, subtract, and multiply complex numbers. So you actually can also divide complex numbers, but for today's lesson, we're not going to do that. Right? So if we look at this, we're going to treat the imaginary part like a variable, but remember I is not actually a variable. So when it says simplify 3 plus 5i and 2 minus 4i, if we think of this as 3 plus 5x plus 2 minus 4x, you can easily simplify this together, right? So the same properties that you would use for that is going to be the same properties for I. So what I'd like for us to do is to rewrite this without parentheses. 3 plus 5i plus 2 minus 4i. And now all we do is combine like terms. Really, that's it. So 3 plus 2 is 5. 5i plus minus 4i is positive 1i, but instead of writing 1i, we're just going to write 5 plus I. That's all there is to it. There isn't a trick. That's it. So we look at number 2. Again, some of you are going to be in the habit of just changing signs, but I don't want us to do that. Instead, I want you to rewrite it without parentheses. So 4 minus 6i. And then if we distribute the negative sign, minus 3 plus 7i. And again, all we're going to do now is combine like terms. So 4 minus 3 is 1. And then negative 6i plus 7i is a positive 1i. So we have 1 plus I. Now question, is it the same to say I plus 1? Is that the same? Well, would you agree that 2 plus 3 is the same thing as 3 plus 2, right? So yes, this would also be the same thing. You could say that as well. All right, let's look at problem 3. 8 plus 5i times 2 minus 3i. So we have a binomial times a binomial. How do we multiply those? Well, you can either FOIL, you can distribute, or you could even use the box. All right, so I'm going to use the box method. So I have 8 and 5i, 2 and negative 3i. Okay, so 2 times 8 is 16. 2 times 5i is 10i. Negative 3i times 8 is negative 24i. And then negative 3 times I times 5i is negative 15i squared. Just like if you were doing the regular box, we could say 16. We can combine these two together, remember. Negative 24i plus 10i is negative 14i. If you wanted to, you could have written that out. And then I have a negative 15i squared. Remember at the beginning of the lesson when I said, don't forget, when you have I squared, it always becomes -1. So what we're going to do is multiply 15 times negative 1. So I can rewrite this as 16 minus 14i plus 15. Right? Because a negative 15 times a negative 1 is a positive 15. And now you would say we're not quite finished because now I can combine 16 and 15. So 16 plus 15 is 31 minus 14i. Alright? Remember, if it's just regular I, we leave it. The only time we change it is with I squared. Alright, let's go on to number 4. You try number 4, and I'll do it on the board without talking. So you should have 36 plus 18i minus 18i minus 9 squared. In this example, I did not combine these together. I just wrote them out. We know that 18i minus 18i cancels out to be gone. So I only have 36 minus 9i squared. But as we said in the previous example, whenever you have I squared, we change that to be negative 1. And then we multiply negative 9 times negative 1, so I should have 36 plus 9. And 36 plus 9 is 45. So my answer here is 45. In fact, in this problem, there is no I at all. And that's okay. Sometimes the I will disappear. Alright, in problem number 5, I have 9 minus 7i squared. You guys remember what that really means? Yes, it means we actually have to write it twice, right? So this really means I have another 9 minus 7i here. And now, again, this becomes a problem that you can distribute, or you can FOIL, or you can use the box. So let's go ahead and do that. Whichever method you prefer. So you should have 81 minus 63i minus 63i plus 49i squared. Remember, there are a couple things we need to take care of here. Negative 63i and negative 63i. So I should have 81, 63i, negative 63i and negative 63i is a negative 126i. And then we talked about earlier again, if there's an I squared, it becomes negative 1. So 49 times negative 1 is negative 49. And then my last step here is to combine 81 and negative 49. So 81 minus 49 is 32, I believe, minus 126i. All right, if we look at number 6, our first instinct is to distribute, right? But what did I tell you? Whenever we have I squared, remember whenever there's I squared, we should always be taking care of it first. If you don't take care of it first and you distribute it to the second thing, you're going to have I cubed. And we don't have any work for I cubed right now. We don't have a way to make that work. So what we're just going to do is we're going to take care of this I squared and make that a -1. So 8 times -1 is -8 times 3 minus 2i. And then we're going to distribute the -8. So then this becomes -24 plus 16i. So remember, whenever you see an I squared, take care of that first by multiplying by -1. Alright, then we talked about how Algebra 2 is all about story problems, right? So we can use complex numbers or used with electricity. In these problems, J usually represents the imaginary unit. The impedance in one part of a series circuit is 7 plus 8J ohms, which is just the unit of measurement, and the impedance in another part of the circuit is 13 minus 4J ohms. Add these complex numbers together to find the total impedance in the circuit. If we are looking at this problem, the only thing they really are asking me to do is to do what? Anyone know? All they want you to do is add the complex numbers together. So all we're going to do is take 7 plus 8j, we're going to treat j like an imaginary number, plus 13 minus 4j. That's all we're doing here. This is not a bad story problem. 7 plus 13 is 20. 8j minus 4j is 4j ohms. That's it. See, story problems aren't bad. Alright, that's it for this lesson. That was a really easy, quick lesson. I think you have 10 problems to do, so I'll give you about 15 minutes to do those 10 problems. Check your answers with your neighbor and work together, okay?